All right, next up, we'll talk about catalysis. So this is a huge industry. It's approximately, I don't know, I found this on the internet, $25 billion industry. And it's a huge focus on chemistry. A huge number of chemists and researchers focus on catalysis. So huge focus of research. And we'll touch back on this when we get to our transition metal and coordination compound stuff. We'll learn about it a little bit more in depth. But think about what catalysis is, right? It's the use of a catalyst. And remember, catalysts make reactions faster. They make them use less energy by lowering the activation energy. And they're not used up in a reaction so you can use them again and again and again. So you can see why it would be useful to make a reaction faster and use up less energy and then be able to use that thing again and again and again. And so the way catalysts work is that they lower the activation energy. And so let's take a look at some examples of this. So we've got energy here. We've got A, our reactant, B, our product, and then I'll draw this as kind of the normal activation energy required. So what would a catalyst do? It's going to lower this activation energy, right? So maybe look something like this, right? Our activation energy is lower. And so think about the Arrhenius equation, it's faster. And so sometimes a catalyst does not change the mechanism of the reaction. And other times it does. So on the left, it didn't change the mechanism of the reaction, it went from A directly to B, so no difference there. Here we have energy reaction. We're going from A to B again, right? Here's kind of our normal pathway with this large activation energy. Then maybe our catalyst does change the mechanism of this reaction, right? Because now we have an intermediate. So we have a first activation energy, and then we have a second activation energy. Now remember, the activation energy is going to be from your kind of starting point, in this case, the intermediate, to the top of the hump, right? So that's the activation energy here. And this time it did change the reaction mechanism because now we have an intermediate that we previously did not have. Right? And remember, you can isolate an intermediate. So sometimes it doesn't change it, sometimes it does. And then here's just a picture from the book as well, right? The blue is the uncatalyzed pathway, and then the red is the catalyzed pathway. You see it lowers the activation energy, and in this case, it does change the mechanism.